In every spy movie, there's a scene where the intelligence agency, looking at a screen, says, "Enhance Sector 7." And just like that, the image from a satellite hanging in orbit zooms in until we can read the newspaper headline in a person's hands on the ground. But what if we aimed not a fictional spy satellite at the Earth, but the most powerful of all real telescopes, the Hubble Space Telescope? Could we actually see such details? The answer is an emphatic no, and the reasons why are far more interesting than you might think. The first problem that comes to mind is the atmosphere. It's what interferes with ground-based telescopes, causing stars to twinkle and blurring the image. But Hubble is in space, at an altitude of over 500 kilometers, far above the main part of the atmosphere. So for Hubble, atmospheric distortion is not a problem when it looks down, just as it isn't when it looks up. So it's not the atmosphere. Then perhaps the problem is resolution. The Hubble is a gigantic telescope with a mirror nearly 2.5 meters in diameter. Its resolving power is phenomenal. It can distinguish an object the size of a soccer ball from a distance of 400 kilometers. But the key word here is can. Even for Hubble, there is a physical limit to the detail it can capture, which depends on distance. For example, Pluto, located at the edge of the solar system, looks like just a blurry, pixelated blob to Hubble. The Earth, of course, is much closer. From its orbital altitude, Hubble could distinguish objects about 15 centimeters in size. That's enough to see an individual person or a car, but completely insufficient to read a license plate or a newspaper headline. The image would be very blurry. But we would never even get that blurry image, because the main, non-obvious problem is motion. Hubble doesn't hang motionless in space. To keep from falling to Earth, it has to move at an enormous speed, about 7 kilometers per second. That's 20 times faster than the speed of sound. From Hubble's perspective, it's not flying over the Earth. The Earth is speeding past beneath it at that same monstrous velocity. Trying to photograph an object on Earth from Hubble is like trying to photograph an ant on the asphalt from the window of a race car. Any exposure, no matter how short, would result in the image being a smeared streak. But wait, Hubble can rotate to track distant stars and galaxies. Maybe it could rotate to lock its gaze on a single point on Earth. In theory, yes, but in practice, no. The problem is inertia. Hubble is a machine the size of a bus, weighing 11 tons. To turn it, massive gyroscopes are used, and they are very, very slow. Hubble's maximum rotation speed is about 6 degrees per minute. That's the speed of the minute hand on your watch. But to track a point on the Earth's surface, it would need to rotate at a rate of about 1 degree per second, 10 times faster than it is physically capable of. Any attempt to make it move faster would lead to vibrations that would completely destroy the image. So, if we were to point Hubble at the Earth, we would get a very blurry and horribly smeared image, on which absolutely nothing could be distinguished. The myth from spy movies is busted. But there's a catch. We've been talking about Hubble, a scientific telescope. But military reconnaissance satellites also exist. Their technologies, of course, are classified, but most experts agree that they possess far more advanced tracking systems and adaptive optics than Hubble. They fly in lower orbits and are likely capable of capturing images with a resolution of a few centimeters. So, while Hubble can't read your newspaper, you can't be entirely sure that someone else isn't. In the end, this is one of those cases where reality might be just as intriguing as Hollywood fiction.